Have you ever wondered how life began on our planet? It's a question that has puzzled scientists for decades, and one that continues to intrigue us to this day. Join us on a fascinating journey back in time as we explore the most compelling theories about the origin of life on Earth. From the chemical evolution theory to the extraterrestrial hypothesis, we'll delve into the latest research and discoveries that shed light on this mysterious and awe-inspiring phenomenon. Don't miss out on this mind-blowing adventure. Watch the full video and discover the secrets of how life started on Earth. The origin of life on Earth stands as one of the great mysteries of science. Various answers have been proposed, all of which remain unverified. To find out if we are alone in the galaxy, we will need to better understand what geochemical conditions nurtured the first life forms. What water, chemistry, and temperature cycles fostered the chemical reactions that allowed life to emerge on our planet. Because life arose in the largely unknown surface conditions of Earth's early history, answering these and other questions remains a challenge. When did life on Earth begin? Earth is about 4.5 billion years old. Scientists think that by 4.3 billion years ago, Earth may have developed conditions suitable to support life. The oldest known fossils, however, are only 3.7 billion years old. During that 600 million year window, life may have emerged repeatedly, only to be snuffed out by catastrophic collisions with asteroids and comets. The details of those early events are not well preserved in Earth's oldest rocks. Some hints come from the oldest zircons, highly durable minerals that formed in magma. Scientists have found traces of a form of carbon, an important element in living organisms, in one such 4.1 billion year old zircon. However, it does not provide enough evidence to prove life's existence at that early date. Where did life on Earth begin? Two possibilities are in volcanically active hydrothermal environments on land and at sea. Some microorganisms thrive in the scalding, highly acidic hot springs environments, like those found today in Iceland, Norway, and Yellowstone National Park. The same goes for deep-sea hydrothermal vents. These chimney-like vents form where seawater comes into contact with magma on the ocean floor, resulting in streams of superheated plumes. The microorganisms that live near such plumes have led some scientists to suggest them as the birthplaces of Earth's first life forms. Organic molecules may also have formed in certain types of clay minerals that could have offered favorable conditions for protection and preservation. This could have happened on Earth during its early history or on comets and asteroids that later brought them to Earth in collisions. This would suggest that the same process could have seeded life on planets elsewhere in the universe. What are the ingredients of life on Earth? The recipe consists of a steady energy source, organic compounds, and water. Sunlight provides the energy source at the surface, which drives photosynthesis. On the ocean floor, geothermal energy supplies the chemical nutrients that organisms need to live. Also crucial are the elements important to life. For us, these are carbon, hydrogen, oxygen, nitrogen, and phosphorus. But there are several scientific mysteries about how these elements wound up together on Earth. For example, scientists would not expect a planet that formed so close to the Sun to naturally incorporate carbon and nitrogen. These elements become solid only under very cold temperatures, such as exist in the outer solar system, not nearer to the Sun where Earth is. Also, carbon, like gold, is rare at the Earth's surface. That's because carbon chemically bonds more often with iron than rock. Gold also bonds more often with metal, so most of it ends up in the Earth's core. So how did the small amounts found at the surface get there? Could a similar process also have unfolded on other planets? The last ingredient is water. Water now covers about 70% of Earth's surface. But how much sat on the surface 4 billion years ago? Like carbon and nitrogen, water is much more likely to become a part of solid objects that formed at a greater distance from the Sun. To explain its presence on Earth, one theory proposes that a class of meteorites called carbonaceous chondrites formed far enough from the Sun to have served as a water delivery system. The Hadean Earth. Discovering the answer as to how the very first life began on Earth has long been a challenge for scientists. Could life have spontaneously appeared on Earth? If so, how could this occur? And does this mean that other planets with similar environmental conditions also contain life? We know that life on Earth is built around compounds that contain elements such as carbon, nitrogen, hydrogen, and oxygen. Complex sequences of these elements bond together, forming the very building blocks of life. They form essential organic molecules, such as sugars, enzymes, proteins, and DNA. However, these organic molecules did not naturally exist on Earth during the Hadean Aeon, when the first origins of life appeared. The elements required existed only in inorganic form, bound up within the rocks, atmosphere, and the early ocean. The earliest Earth was a naked planet. The Hadean bioscience colleagues describe it as having no ocean or atmosphere when it first formed. These eventually appeared around 4.37 billion years ago, after Earth had been pelted by aqueous asteroid material. Once there was liquid water and an atmosphere, there was a greater chance for prebiotic life to form, the chemical precursors to life on Earth. The first traces of life recorded on Earth are thought to be as old as 4.2 billion years, indicating that life may have evolved within 200 million years after the first appearance of liquid water. Requirements for early life. We know that all the key elements for life are found on Earth, but they do not easily form organic compounds. Early experiments during the 1950s showed that amino acids could form in water condensation within experimental conditions that mimic the atmosphere of early Earth. However, for this to occur, a powerful energy source was required. The input of energy caused chemical reactions capable of creating compounds based on hydrogen, carbon, and nitrogen that would eventually form organic molecules. In conclusion, the origin of life on Earth remains one of the greatest mysteries of science, and there is still much to be discovered and understood. However, by exploring the various theories and evidence available, we can gain a deeper appreciation for the remarkable complexity and beauty of life itself. So why not delve deeper into the fascinating world of science and discover even more about the origins of life? Subscribe to our channel for more exciting content on this and other fascinating scientific topics. Don't forget to hit the like and share button, and let us know your thoughts in the comments below. Thanks for watching.